So today we're going to learn about the fundamental theorem of line integrals, which is a really integral part of the three-dimensional calculus and multivariable calculus classes. So if you recall from Calc 1 and Calc 2, there's the fundamental theorem of calculus, which states that the prime of your function f is the integral of that is equal to the function at your endpoint b minus the function at your start point of a. So if we keep this in mind, we're going to apply this to a three-dimensional plane with multivariables. Okay, so putting this in a three-dimensional plane, we have the fundamental theorem of line integrals. So if we consider the scalar function, which means non-vector, f of x, y, or we'll probably deal with more likely f of x, y, z, which is a three-dimensional surface. So its gradient is the partial derivative, so the derivative with respect to f of x, f of y, and f of z makes up the gradient. C, which is the surface that it will cover, that's why the integral is of c, will be the vector function r of t. And the function will go from the start point of a to the end point of b, as shown with a is less than or equal to t, t is less than or equal to b. So if we put this all together into one integral, we have a fairly simple function that the integral along the surface of c, which equals to r of t, of the gradient of f with the dot product of the derivative of r of t equals the actual function f here at where the vector function r of t is at the endpoint of b minus the function of f at the vector function at the start point of a. So kind of the problem with the fundamental theorem of line integrals is that it only applies in a special case when the vector field that the surface is in is conservative. And the way that you know that a vector field is conservative is if the gradient is equal to the vector field itself. So if the vector field is conservative, there's a couple of things that you can know about the line integral itself. So the line integral in a conservative vector field is path independent, which means that if any path is taken with the same start and end point, so say it starts at -1, ends at 3, it doesn't matter what path you'll take to get there, the answer will always be the same. Also, the line integral for a closed path is 0. So if a equals b, so your a is -1 and your b is -1, the integral itself will equal 0. So that's the fundamental theorem of line integrals. Thank you for listening today and learning more about multivariable calculus.